Hi, this is Mrs. Secorn. If you can find this page in your notebook, we're going to begin. We're going to apply now our trigonometry to real world problems. Okay, so here we have a person. If he's looking straight out here, that's a horizontal line. And if we have the balloon person looking straight out, that's another horizontal line. These lines are parallel, and I'll use a symbol saying they're parallel. What we're going to do is we're going to talk about an angle of depression, the angle formed between the horizontal line and an observer's line of sight to an object below the horizontal. So the guy in the balloon is looking down at the boy, and he looks down. So that's an angle of depression, looking down, okay? Like the Great Depression, things went down, okay? And the boy, he's looking up at the balloon. So that's an angle of elevation, like an elevator going up from the horizontal line. This is the horizontal line going up. So that's an angle of elevation. Let's say that the angle of depression, this man looking down, was 38 degrees as he was looking down at the boy. Well, that's the same exact measurement as the boy looking up to the man, 38 degrees. Okay, so that's important for our problems. Let's try one. Okay, we have a bird. A bird in a tree spots a worm on the ground at an angle of depression of 47 degrees. If the bird is 72 feet from the ground, how far is the worm from the base of the tree? Okay, we're going to make a right triangle. Fill in what we know. Okay, a bird in a tree, the angle of depression is 47. So I'll draw a horizontal line out here, and then I'm looking down to the worm. This angle is 47 degrees, the angle of depression. That makes this angle also 47 degrees. There's that right triangle. And it says the bird is 72 feet from the ground. I need to find out this distance, how far the worm is to the tree. Okay. All right, so SOHCAHTOA. Good idea to write it at the top of every page. And we're looking at our reference angle, 47. Remember, this is the hypotenuse, and it's opposite, adjacent. Opposite the reference angle, adjacent. Okay, that would be TOA, right? Tangent. Okay, so the tangent of 47 degrees, opposite 72, adjacent x. We'll do it as a proportion, put it over 1, cross products, x times the tangent of 47 equals 72. Or, if we divide both sides by the tangent of 47, these would cancel out, and x would equal, let's go to our calculator. Okay, that was 72 divided by the tangent of 47. And it says it's 67.1. 67.1. So our x is 67.1 feet. That's how far the worm is from the tree. Next problem, example 2. Here we have a 92-foot extension ladder resting on the top of a fire truck with its base of 10 feet. So from here to here is 10 feet. When the angle of elevation of the ladder is 75, how high up the building will it reach? Okay, this is a little more complicated and the picture's not very good. Let's go ahead and I think I'll try blowing it up here. Okay, so this is 10 right here, and this is 75 degrees, and if I want to find this will, my hypotenuse is this one. That is how high, 92 feet. And I want to find out how high up the building is. Well, I'm first going to have to find this distance right here, x. Okay? Can you tell that triangle? Let me just draw it real quick out here. This ladder is 92. I'm finding x. And I know this angle is 75 degrees. SOHCAHTOA. Let's see what I got here. Opposite hypotenuse. Sine. So the sine of 75 equals, opposite is x, hypotenuse is 92. Cross products. Let's put it over 1. X equals 92 times the sine of 75 degrees. Okay? We'll clear this. And we have 92 times sine of 75, and I end up with 88 point, I think I'll say 88.9. Alright, so this then was 88.9, the distance here, and I want to add my 10 feet that the truck sits up high, so I get 98.9 feet. That's how high up the ladder is on the building. 98.9. Example 3. A stranded boater tries to gain attention of a rescue helicopter that is 300 feet away. If the helicopter is hovering at 70 feet, what is the angle of depression from the pilot to the boater? Okay, so let's drop in a vertical distance. Take this over to our boat. Take this up here. I have an angle of depression, which is unknown. I do know that this boat and helicopter are 300 feet apart, and this distance is 70. Okay, so it looks like it is this angle right here, it equals that, right? Because this is the angle of depression equals the angle of elevation. So opposite hypotenuse. Opposite hypotenuse is sine. Sine, don't know the angle, so we'll call it x, equals 70 over 300. So x equals sine inverse. When you don't know the angle, you take the inverse. And we'll go to our calculator. Remember, angles are shifty dudes, so we'll hit second sine. And we'll put in 70 divided by 300. And it looks like the angle is 13 degrees, about 13 degrees. Okay, so that's 13 degrees here. The next problem, example 4. From a sailboat, the angle of elevation to the top of a lighthouse is 311 feet away is 17 degrees. Find the height of the lighthouse. Okay, so we're talking about this height. This is 17 degrees, the angle of elevation to the top of the lighthouse. And this distance is 311. We want to find out how tall that lighthouse is. Opposite, adjacent, right? Opposite, adjacent, because that's the hypotenuse. That's tangent of 17. Opposite is x, adjacent is 311. Cross products, x equals 311 times the tangent of 17. Go to our calculator. Okay, so that was 311. Times the tangent of 17. And it looks like it's 95.1. So x is 95.1 feet. That's how tall our lighthouse is. Okay, and the next problem, number 5. An antenna stands on top of a 140-foot building. From a point on the ground 112 feet from the base of the building, the angle of elevation to the top of the antenna is 62.1 degrees. Find the height of the antenna. Okay, so our building, 140. That's from here to here. We need to find out how tall this antenna is. Well, we do know that if we draw in a triangle here, that this distance is 112. And our angle of elevation to that top of that antenna is 62.1 degrees. If we can find this distance, then we could subtract our 140 to find out how tall that antenna is. So let's find the top, the antenna down here, and then we'll subtract the 140. Okay, so opposite, adjacent, tangent of 62.1 degrees equals opposite, which is x, adjacent, which is 112. Cross products, x equals 112 times the tangent of 62.1. Putting that in our calculator. Okay, so what was that again? 112 times the tangent of 62.1. Okay, so the building then is, would you say 211.5? Okay, so x is 211.5 feet. Now that's the whole distance. So if we subtract our 140, we'll find out how tall the antenna is. So 211.5 minus 140. Let's see, bring down the decimal one. 71.5 feet. That's how tall that antenna is. 71.5. And the last one. Okay, this one's tricky. I'm going to blow up the picture here. Okay. We're going to have to read it, though, from the paper. Okay. A building is 20.2 meters from a cell phone tower. All right. And from the top of the building, so if you're standing here, from the top of the building